Question says a block of mass 2 kg is at rest on horizontal floor. The coefficient of friction between the block and the floor is mu. A force of magnitude 12 Newton acts on the block at an angle alpha to the horizontal, where tan alpha is 3 by 4. Before moving on, I would like to split it up. So if this is alpha, tan alpha is perpendicular over base. Using Pythagoras theorem, this is 5. So indirectly I have values for cos and sin alpha as well. When applied force acts downwards as shown in figure 1, the block remains at rest. Show that mu is greater than 6 by 17. So when we split this in two, this is 12 sine of alpha, this is 12 cos of alpha with respect to the given angle. And we would know that the block should naturally move towards right hand side. And the question states that when applied force acts downwards, the block remains at rest. That means friction is actually acting opposite to this. So friction is basically equal or more than the applied force. That is why the block is not moving. So what do we do is force towards right hand side, which is 12 cos of alpha. I would say this is less than equal to friction. That is why the block is not moving. So 12 cos of alpha from this triangle, cos alpha is base over hypotenuse, which is 4 by 5, is less than equal to friction is mu r. Coming back to the diagram, this is the downward force 12 sine alpha. So if it is acting downwards, normal direction is acting upwards, which is equal to 12 sine alpha, and there is no other force in this case. So 12 sine alpha, this is 12 into 4 by 5 mu, that is 12 sine of alpha. Replacing it again, sine alpha is 3 by 5, so 12 4 by 5 less than equal to mu 12 sine alpha is 3 by 5. Now we simplify for mu. We cancel out 12 with 12, 5 with 5, and I missed out one thing. Block was for 2 kgs. So this is downwards 20 newtons. So when writing the vertical forces, these two are downwards and R is upwards. So R is equals to 12 sine alpha downward plus 20. 12 sine alpha is 3 by 5 plus 20. Simplifying this, get 12 into 3 divided by 5 plus 20, 136 by 5. 136 by 5. So 12 into 4 by 5 on left hand side is 48 by 5 equals 136 by 5. We get rid of this. 48 by 136 is less than equal to mu, and 48 by 136 is 6 by 17. So 6 by 17 is less than equal to mu, or we say mu is greater than equal to 6 by 17. Any confusion in the first part? Now, second part says when the applied force acts upwards as in figure 2, the block slides along the floor. This is 12 sine alpha, this is 12 cos alpha, and R is upwards, weight is downwards, 20 newtons. And when it is sliding, friction is towards left hand side. So we can say, now we'll adjust the sign greater than. Right hand force is actually greater than left hand force, that is why it is moving. So Let's split it up quickly. This was 12, that's alpha. 12 cos alpha, this is 12 sine alpha. R is upwards, weight is downwards, and friction is to left hand side. So in the second case, 12 cos alpha is actually greater than the friction. So 12 cos alpha greater than friction is mu r. 12 cos of alpha is greater than mu, and r, upward forces added equals downward force. R plus 12 sine alpha is equal to 20. So R is equals to 20 minus 12 sine alpha. 20 minus 12 sine of alpha. So 12 into cos of alpha using the same triangle. Cos was 4 by 5 is greater than mu 20 minus 12, and sine alpha is 3 by 5. Using calculator, this is 48 by 5 greater than mu 20 minus 12 into 3 by 5 is 64 by 5. So 48 by 64 is greater than mu, and 48 by 64 gives us 3 by 4. So basically mu is less than 3 by 4 in this case.